We can use a formatted random access file to store and retrieve multiple objects unencapsulated in a class and outside of an array. Looking at random access files, and everything we've done so far has been utilizing a class or objects built from class and arrays. We've been populating arrays and doing sorts and things. Here's another way. I'm just going to show you a different way of implementing random file access. And in this example, we're not going to use a class, so nothing to serialize, and we're not going to use arrays. All right, we're just going to use a file. You'll need the same imports, from the I/O package that we've been using before for I/O exception and random access file. You'll need something for input. I'm using a scanner object. You could opt to use something like a line number reader or a JOption pane, show input dialog or something like that. But those are the imports, the things you'll need. Now let's take a look at our globals real quick. All right, here's our scanner object. We're just building it. First, we need to calculate the total file size by adding up all the bytes of data that need to be saved and multiplying the result by the number of records. And now we have two finals here, and these are very important. Because we're not using an array, we're going to basically create a file and randomly move the file pointer position through the file to find records instead of having to access it sequentially. Then we need to know the exact size of a record and the number of records, and we have to multiply these two together. That's necessary to know how to initialize the file and then later to seek and find records throughout the file. This will tell us how far we need to skip up and down when we're looking for something in the file. Remember that random file access can be a lot more efficient than sequential file access. Now it depends on the task at hand or what you're using it for. It's not always the best tool for the job, or it's not always the most practical thing if you're just simply trying to save a configuration file or serialize an object or something. But it's an option. It's there. And so we're going to kind of take a quick peek at it or a quick look at it. Okay, so we have these finals. They're final. They're constant because they should not change. Just like if we were to instantiate an array of 100 person objects, we would not want, we couldn't modify the length of the array once it's been built. Okay, now, array list objects, they're, our array list class objects, they are dynamic. They're resizable, but arrays are not. So we're doing the same thing here with these finals. We're just making these values constant. The file pointer position, yes, it's going to change, and it is what it says it is. It's going to be used to track the file pointer throughout the file and to manipulate and position it. Okay? All of these are public and static because they're global. All of our functions are public and static because we're not going to instantiate this class. We're just going to access these functions, these methods, these data members directly. So that's part of our globals. Okay, now if we were using a class, these four variables here would be the private data members of the class, and we'd write get and set public accessor methods or functions. All right, if we chose to encapsulate this in a class. And that would actually, in my opinion, be a better way to do it because it's more in line with object-oriented thinking or object-oriented philosophy. The idea of encapsulating what an object is and what an object does and has it is and all that. But just to show you a different way of doing things, I'm not going to encapsulate this data in a class. So these are just loose and floating globals, so to speak. Now, it's important to know, how big a record is. And if this were a class, this would be the sum total of all the data members in the class. In this case, you might think of each of these as a field, so it's a column. The combination of all four of them would be a row. Well, how big is a row? In this case, it's 42 bytes. And how do we figure that out? Well, an integer is 4 bytes, unless it's unsigned or signed. And then here we have a string. And remember that a string is pretty much an array of type characters, so it would be 1 byte per character. So if I initialize my string gamer name to be A through Z, easy, there's 26 characters in the alphabet. That's going to be 1 byte times 26, or 26 bytes on the string. All right. Another integer, that's another 4 bytes, and a double gamer kills ratio is 8 bytes. So we just need to add all these together, right? 4 plus 26 plus 4 plus 8 gives us 42. And I didn't plan it this way, but if you're a Douglas Adams fan, hey, 42, the meaning of life. Didn't even plan that. So there are our globals, and they're sitting there waiting for us to utilize them. Let's take a look at the rest of the functions and see what's happening or what's going on. in the main function, here's our menu. We have a string choice, and we're using a string. We could use a character, but the problem is, down here, if they type in QIED, we're fine, but what if they type in the whole word, quit or initialize database? If we were only using a single character instead of a string, that would overflow the 1 byte or 2 byte, depending on how you look at it, character size of our variable, and then it would create problems. It would spill over, kind of overflow the buffer, and we'd have loop problems or other problems in our program. Our program could even crash. So to make it a bit more resilient, we're going to use an entire string here. And again, if we were using JFrames, a graphical interface, or if we were using JApplets or something, that wouldn't be an issue. But in the console, we have to kind of think a little bit about bulletproofing, because the user could type anything, and it might not be the right size, it might not be the right data type. So we're using a string. All right, we display the menu choices. We take input as a string. Let's check and make sure that it's not empty. If it is, we need to set it to be something other than null. Otherwise, when we call this to lowercase and convert it to lowercase, we're going to be in trouble. It would crash. We get like a null pointer or null object exception. So in this case, that would prevent that, save us from that. Now, in a switch statement, we can't switch on an entire string, but we can switch on a single character, and that's all we care about, the first character of the string. And that way, because it's a whole string, we can ignore the rest of it. It won't cause it to loop or overflow. We'll just switch on it once it's been converted to lowercase and call the appropriate function. Okay? Before we can write to or read from the random access file, we need to format it with the appropriate data types and sizes. The basic process to write to a file randomly is, first, create a random access file object. Second, write the data to the file with the appropriate write function based on the object's data type. Once again, here are some type-specific write methods. WriteInt writes integer data, WriteDouble writes double data, WriteETF for Unicode text writes string data, WriteBoolean writes Boolean data, and WriteChar or WriteChar writes character data. The first function that we absolutely have to call is initialize random access file. If we don't do this first, we'll have big problems. And the reason is this formats the file and sets it up to be the right size so that we can seek and position the file pointer back and forth in the file to actually randomly access records in the file. So how do we do that? Well, just like any other I/O process we've been looking at, it's always in try and catch blocks in Java. We catch an I/O exception, input output. We need to build or instantiate a random access file object. And you don't have to, but I like to do that in the try blocks as well because, again, things could go wrong here. What if you don't have permission to create a file on that directory or in that partition? Or what if you don't have enough space, or who knows? Lots of things could go wrong. Now I need to create a for loop, and this is where we have to go through and pretty much format the file, kind of do a zero write. And that's where number of records comes in. Number of records being 100, just like in all the examples we've done utilizing arrays. Okay, and then look at our data here. Gamer ID is an integer, gamer name's a string, gamer score is an integer, and gamer kills ratio is a double. So we have to go integer, string, integer, double. And that's all we're doing here, right? Write int, write UTF, which is a string, write int, which is integer, and write double, which is double. All right, so we do that 100 times in this for loop, and that formats the whole file and sets it up. It's all empty. It's just 0 and A to Z, so to speak, but it's ready now. Now we can write data to it, and we can read data from it, okay? And then, of course, we have to catch it, and we're just going to say IO file access error if something goes wrong. Okay, so we've initialized the database now, and we'll test it in a moment. Now what do we need to do? Once the random access file has been formatted, we can use the seek method to position the file pointer at the precise position where we want to write to the file. We need to enter data. How do we enter data, and how do we enter it at the right place? Well, we have to be able to get input on all of these variables, and then we have to manipulate or massage the data into the right size and the right format before we write it. So taking a look at enter data, we have two strings here, choice and temp. Choice for the menu choices, and temp for taking input and doing things like parsing and so forth. Again, it's a basic I/O operation, so it needs to be inside or within try and catch blocks. And also, again, we need to catch an I/O exception. If something, if an exception is thrown, it's going to be an input-output I/O exception. So that's what we want to catch. So back up to the top here, what do we do inside of our try block? Well, just like before, when we enter data, we have to build our random access file object. We'll call it the same out. Here we have a while true loop. All right, so while the first character of our string choice is not Q, so this is our sentinel value when we enter Q later, then that's when we'll break out of this loop or bust out of this while true loop. Otherwise, we'll keep looping, and we'll allow them to enter and save more than as many gamer objects as they wish, or as many gamer IDs as they wish, and stats. All right, how do we get out of this while true loop? Again, down here, we're asking, do you want to quit? Yes or no. Again, we're doing a little bit of bulletproofing and validating, and we're just going to switch. And if they, hey, if they want to quit, we set choice to be Q. Otherwise, we'll continue. All right, so that's all we're doing in this while true loop. We'll just keep it going until they decide they no longer want to. Once the random access file has been formatted and written to, we can use the seek method to position the file pointer at the precise position where we want to read from the file. The basic process to read from a file randomly is first create a random access file, and then read the data from the file with the appropriate read function based on the object's data type. Once again, here are some type-specific read methods. Read int to read integer data, read double to read double data, read UTF or Unicode text to read string data, read boolean to read boolean data, and read char or read char to read character data. So now we need to get those 4 variables. The first is the gamer ID. So we're going to take input via our scanner object. Now, we could use things like next int and next double. We don't have to use next line, but then we have to worry about catching different exceptions. And I'm trying to shorten the learning curve and keep this brief. And we've been catching number format exceptions for quite some time now. So to avoid having to introduce new exceptions and things that we have to catch, I'm going to continue just using next line instead of next int or next double or anything like that. No problem. We can still parse it. It comes in as string data. We integer parse int it. And if they type in some craziness, supercalifragilistic or banana, then we'll simply catch a number format exception and default it to 0. Okay? So we do want to, kind of validate or bulletproof that a little bit there in case they type in some craziness that we don't want. Then the next value is pretty easy. It's just a string. We don't have to parse it. However, we do have to worry about the length. And what I mean is, look, if you look up here, the initial value of our string was 26 characters. Well, when we initialize the file, guess what? That field, all throughout the file, for all 100 records, is 26 characters. So we need to be extra careful, extra special careful, that when we get the gamer's name, that we manipulate and massage that string so that it's exactly 26 characters. So if they have a really long name and it goes over 26, we need to chop characters off. And if they have a really short name and it's less than 26, we need to add some, pad it out with some spaces or some 0 values here. So we're going to ask, the name for the gamer. We're going to take input as a string, but we're going to store it not in gamer name yet, but in a temporary string. Here's our temporary string up here, okay? And there's only 3 possible logic states here, right? Think about it. We're doing a comparison, and in a basic comparison, there's just 3 logic states we have to worry about. It's either greater than, or it's less than, or it's equal to, okay? So we have to think about that, and then we have to think about what are we going to do for each of those, logical conditions when we're doing a comparison. So first, let's take our string, and we'll get the length of each one of them, and, what happens if they have a really long name and it's bigger, it's greater than the 26 characters that gamer name needs to be, gamer name.length. Well then, we can use the substring function, and what this will do is we'll simply generate a substring, we'll get the first 26 characters out of it, supercalifragil whatever, and we'll just chop off the rest, okay? Now, hopefully nobody has a longer name than that, and we can play with that, but we need to format this so that it's not going to be bigger, otherwise it will overflow the record size. So we just have to format it and make sure it's not going to be bigger than the original default string when we initialize the file. So that's what we'll do there using substring. And that would handle it or take care of it if their name, if temp happens to be greater than or larger than the 26 character gamer name. Now the next possibility is, what if it's a short name like Charles, 7 letters or 7 characters? So there's a difference of 19. If I were to subtract that from the 26 character value, the length would return from gamer name. So if it's less than, let's compute the difference. So here's an integer difference, and it will be set to be equal to, or assign the value of the result of gamer name.length minus temp.length, okay? We'll just create a for loop, and we're just going to do some simple concatenation. So we'll add 19 spaces. Hypothetically, say I type in Charles, it would be like 19 spaces, or however many, to equal or amount to 26 characters. And then finally, when we get all done, we'll take that and we'll assign it to gamer name, and then it's all ready to be set, okay? Or ready to be written to the file. And then, of course, in the unlikely but still possible event that they're the same, well, we'll just assign it. Okay, the next one, score. Again, it's not a string, it's an integer, so we have to do some parsing. We need to catch a number format exception in case I type in some weird thing that shouldn't be there. And then kills ratio, it's not a double, it's not an integer, it's a double, but we still have to parse it because it comes in as a string whenever we call next line. So we have to convert it to a double, and again we have to catch a number format exception in case I type in some weird thing that they shouldn't. Okay, so now we get down to here. By the time we get down to here, we've taken care of manipulating and massaging and sizing all of the field data, all the variables, to be what they need to be, the right size and the right data type or format to write to the file. So now we can actually begin the process of writing to the file. How do we do that? Well, their gamer ID, whatever they typed in, remember that there is an offset, a fence post, an off by 1 situation here. Humans like to start at 1, computers like to start at 0. Okay, so to make it user friendly, yeah, we'll let it appear to the user to be 1, but we need to subtract the 1, and actually, if this were the first record, say, it would be record 0, not record 1. So file pointer position, we're subtracting the 1, and now we're going to perform a seek operation, and in our seek operation, it's going to be the file pointer position times the size of a record. And of course, the size of a record is 42 in this example. All right, there's our constant, 42. And let me get down here. Okay, so we're going to go find that position, wherever that position may be. And now we're just going to perform writing these 4 variables, and we need to call the right method based on the data type. Gamer ID was an integer, so we call write int. Gamer name is a string, so we call write UTF, Unicode text. Gamer score was an integer, so we call write int. And gamer kills ratio was a double, so we call write double. And we just, do you want to continue, yes or no, and then they can decide that, okay? So that is enter data. And then finally, the last thing is, okay, so we're able to enter data. Now what about displaying data? Let's take a look at that and see how that works. So if we display data, very similar to what we did when we entered data, we have the same 2 strings here. Try and catch, because it's an I/O process, we have to catch an I/O exception just like we did before. We build a random access file object just like we did before. And our same sentinel value and a while true loop, and down here they can decide whether or not they want to keep going or whether or not they want to quit. Okay, so all that is the same. And now all we really need to do is get one piece of information. Which gamer ID do they want to display in this example? Now we need to call try, because we're going to have to convert what they type, which comes in as a string, via the scanner object, and next line, we'll have to parse it, convert it to an integer. It's possible if they type some bad data in that it might not be numerical. And if it's not numerical, we have to catch a number format exception. Okay, we'll default to 0 if that happens. Otherwise, we're set with the ID, so we'll set the file pointer position to what they type in minus 1, again to offset for a fence post situation, or off by 1. And now we're going to seek the file pointer position times the size of a record, which in our example is 42. And now we just need to perform the correct read operation for each of our 4 variables. And again, it's data type specific. It's strongly typed. So gamer ID is an integer, so we have to call read int. Okay, gamer name is a string, so we have to call read UTF for Unicode text. Gamer score is an integer, so we have to call read int. And gamer kills ratio is a double, so we have to call read double. Once we do all that, and that information has been safely assigned to our variables, now we can call viewGamer. And down here, viewGamer is just a very simple function that displays the gamer stats by taking these 4 variables and concatenating them to a string literal to show what the variable is or what the value is, along with what the field name is. Okay, so that's sort of our basic program. Now let's test it out. Let's test it. So why don't we go ahead and run our example program here, and we'll just test some things out. Okay, so we're going to initialize the database file. We'll create it, and now let's take a look at it. When we initialize it, it's just pretty much like a 0 array. And if we open it up in Notepad, it won't be able to make much sense out of it. It'll be kind of nonsensical, but this is just that binary data. And you can see some of the formatting. There's the 26 character string there. But it's in sort of, it's not in plain ASCII text or Unicode text, or not like a sequential file would be. All right, so it's initialized. There's sort of our random binary data. Now let's go ahead and enter some data and see how that works. So we'll run it. And gamer ID, let's start with 1. That'll be our first record. We'll go with Charles. And the score. And I got 100. And the kills ratio, 33.3%. How about that? All right. And let's see. We'll go ahead and do another one. Quit. We'll say no. And game ID, we'll do 2. And let's see. We'll do and 125 and kills ratio 45.3. How about that? And we'll say we'll do one more here. And we'll do 3 and here and 205 and 95.5 on the kills ratio. Quit and we'll say yes. Okay. And I'll go ahead and quit now. Exit the program and let's take a look at the file real quick, and then we'll launch it again and read it. So again, if I open it up in Notepad, it's not gonna be very legible, but you can at least see in the formatting there were the different values that we wrote to the file, even though it's not in sequential or in plain Unicode or ASCII formatting. So let's run this now, and that was entered in. Now let's go ahead and run the function to display data. Gamer ID, let's choose ID 1, okay? And here are, gamer ID 1, there's Charles, there's my score, and there's my kills ratio. And then I'm going to say no, and gamer ID, let's display gamer ID 2. Alright, and there's Jacob, and there's his score, and then I'm going to say no. And now let's display gamer ID 3. And I need to set the I could set the precision formatting there, but in this case there's our kills ratio. Alright, and there's our third gamer ID object, and then we'll quit and we'll quit. Alright, so that just shows you another method or another way to utilize random access file objects without arrays, or without having to populate an array with classes of objects.